Hello, in this video we're going to start looking at synthetic division and the uses that it has for polynomials. In this case, we're going to use it to divide two polynomials. So we want to be able to divide polynomials like we do numbers. So if I had 8 divided by 3, that'd be the same as 2 plus 2 over 3. Because I would have that remainder I would have what we call the quotient, and then I would have the divisor and dividend. Now you may not remember all of these words, but you probably remember this big one over here, that remainder. So our idea for synthetic division is to do this kind of division with polynomials. And how we do that is we're going to convert this polynomial we're dividing by into a number. And we're going to choose that number to be what makes it 0. So this is that number associated with the polynomial. Now here, we're going to write the coefficients of the number we want to divide, or the polynomial we want to divide. So we're trying to divide this polynomial, we have these numbers associated to it, by some other polynomial. We have that associated to the 0. So what we do, so we always drop down this first term, and then we're going to multiply in a check. So negative 3 times 3 is negative 9, and we'll add down. So this becomes negative 11. We'll multiply in a check, add down. Multiply in a check, and add down. So just like our normal division, the last thing that we get is going to be our remainder. This is what was left, and we weren't able to divide it out evenly. This piece is going to be our quotient, just like before. And it's going to be associated to coefficients of the polynomial. So we're just making this new polynomial based on these numbers. So if we're going to write out what this fraction is equal to, well, that would be equal to this polynomial we get plus this remainder over what we were dividing by. So you can see how similar this is to dividing our integers. So let's try again. So we want to divide by 2. Again, what makes this polynomial 0. On the top here, we want to write down the coefficients. And what you'll notice is I have some zeros here, and that's because this polynomial is missing some terms. And these terms are important. This would be the difference between dividing, say, the number 14 by 3 and 1004 by 3. we can see even if they're zeros, these placeholders in between actually do make a difference. So we need to include them here. So we drop down the first term, multiply in a check, and add down. Multiply in a check, add down. Multiply in a check, add down. Multiply in a check, and add down. So like before, this last thing that we're getting is the remainder. This is our polynomial. This is the quotient that we're getting after dividing. And we can see this is x cubed plus 2x squared minus 5x minus 10. So our answer is that polynomial we're getting plus the remainder over what we were dividing by. So whenever we're dividing, it's easy to see what we're going to get for our quotient, because x to the fourth divided by x is x cubed, and that tells us what this highest exponent is going to be. All right, one more example. X to the fourth minus 1 over x minus 4. So we again want to divide by 4, the number that makes the denominator 0. We have a lot of missing terms, so we may want to write it out. X to the fourth plus 0x cubed plus 0x squared plus 0x minus 1. So we can see we have 1, 0, 0, 0, negative 1. So we bring the first term down, multiply in a check, and add down. 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 So, just to jump exactly to the answer, this is our polynomial. These are the coefficients. So x cubed plus 4x squared plus 16x plus 64 plus 255 over x minus 4. Now, in future videos, we're going to use this for factoring. Because if we had it so that the remainder was 0, we would actually be able to factor these polynomials. And I'll do a short example of that. So let's say rather than x minus 4, we had x minus 1. And so based on what we saw before, we'll bring the first term down, multiply in a check, and add down. And what we notice is we get 0 here. So we have x to the fourth minus 1 over x minus 1 is x cubed plus x squared plus x plus 1. So if we rewrote this a little bit, we can see the use for synthetic division. It's going to help us factor these very large polynomials. But for this lesson, we're just focusing on the first part, actually being able to divide two polynomials using synthetic division.